Hello and welcome to Physics Problems 1 by 1.
So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself.
So today's problem is we throw the body with V0. It goes and reaches the top, right? H, height. And then when it reaches the top and it's in the apex, we throw another body. And so this body starts to move down, and this body moves up, and they move somewhere. And they want us to find where they move, where they meet. So V0, and there are few things that we can tell right away. First of all, we of course immediately know that if we go from here with V0 and come to the top, and it's our first body, then we can say that at the top the speed equal, pause, yes, correct, it's equal 0 because we reach the top. But according to formula for acceleration, it equals, correct, initial speed minus gt. So it goes up, h is the height, and t is the time. So this is the first formula that we know. And of course we can move gt here and obtain t. And let's do this. Gt equal v0 and t equal v0 over g. This is first thing. The second thing, again, we go from here, we come here, and of course we can write two formulas for h, whichever you want. The first formula is initial speed v0 multiplied by t minus gt squared over 2, because you can live only with this formula. Put here v over g, so it would be v squared over g minus g t squared, it would be v0 squared divided over g squared, and here would be 2. And so h would become v squared over g minus g is gone, v squared over 2g, 1 and 1/2, we have only 1/2 left, h equal v squared over 2g. But of course we don't have to do this. We can simply say that this formula h, we solved so many problems that we know that h equal v final squared minus v initial squared divided over 2a. And in this case final speed is 0, minus initial is v0 squared, and acceleration was negative sign, so it would be minus 2g. And h would become v squared divided over 2g. So we can write this formula right away, but whatever we write, we have t equal v over g, and we have h equal v0 squared over 2g. This is the first thing that we should write, just looking on the first body. But then we have to think about what really they want us to do. And they want us to find where two bodies meet. But if the body meet, let's draw another picture. This starts with v0, and this is falling down with the speed equals 0, because this is what the moment when this reaches the top, this goes down. So, for example, we can put, and let's put y now. I don't want to denote it as x. Previously I always was denoted as with x, but today I am in the mood to call it y. So it would be 0, and I can say that the first body that starts from the top, it starts with, on this attitude, y0 is equal h. Speed plus, because the formula of course, x equal x0 plus v0 t plus at squared over 2, generic formula. Now here not x but y, initial position at this moment when they start to fly towards each other simultaneously. For this body is h, speed is 0, because it's just hanging and starts to fall down free. And acceleration this way, so it would be minus gt squared over 2. And notice I write t, lowercase, because it's at any moment of time. This t is duration of flight from here to here, from here to here. But this t, at any moment, this is a formula. y2 for the second body, okay. Initial is 0, because it's starting from the bottom. Plus, speed is up, so it's positive, v0t, and acceleration still down, so minus gt squared over 2. Right? And I can say y equal y2, and I can say that this is a system of three equations. This is unknown, and t is unknown, for example. The rest, let's say, it's known. So let's get rid of y1, putting it here, and y2 in one step, because it's so simple, because they are equal to each other. So I write h minus gt squared over 2, right, equal v0t minus gt squared over 2. This is one equation. Those three we have reduced by eliminating y1 and y2 to this one equation. And of course on both sides we have this and this with the same sign. So we have h equal v0, and this is this t, time of the meet. So let's put it like not simple time, but t meet, when they meet, right? And so we immediately have the t meet equals h over v0. Okay. And now let's try to reduce it. Let's remember that h is this. So we can say t meet, the moment when they meet is this, v0 squared over 2g divided over v, this is gone, it would become v0 divided over 2g. So the total time is v, and this is a half. So what that means? First of all, we find the moment when they meet, and secondly we say the moment of they meet is 1/2 of total time up and time down. So it takes, for example, 4 seconds to go here, and then 2 seconds before they meet. It takes, for example, 10 seconds and then 5 seconds before they meet. Okay, so now where do they meet? Let me remove this, because we can find where they meet. Oh, that's very simple. Let's find out this distance that this body travels. The first body, for example, let's call this distance d1. And d1, of course, would be initial speed 0 plus g t meet squared over 2. And we can put this here, and we will have d1 equal g t meet would be 1/2, but it's squared, right? So it would be 1/2 over t squared, right? I just wrote simply this, divided over 2, and then let's put d1 equal g, and here would be 2, 1/2, it would be 4, and then this would be t squared, right? gt squared over 2 over 5, but we already know that gt squared over 2 is the whole height, gt squared over 2. So I can say that it is h divided into 4. So it is 1/4 of the height they meet. And that's very natural, because look from the position of this body. This body is falling down, and the distance that it covers is gt squared. So it was traveling 1 second, it covered one distance. But if the time that it travels doubles, that 4 times more the distance. And the only way to satisfy this is that it is 1/4 and this is 3/4. Because during free acceleration, the formula is gt squared with no speed, gt squared proportional to t squared. So if t is increased twice as much, the distance is increased 4 times. So this distance is increased 4 times, and it is full distance. So let me put it another way, so it will become even more clear. So let's put two graphs together for, this is y, remember we decided to call it y, and this is time, and this is t capital, and during this time t capital, this first body is flying with initial speed v0, and it reaches, this is a parabola, and this tangent is alpha, and we can say tangent alpha equal v0. Doesn't matter, but important that during this time it comes to this height. Then the second body is flying, it's flying exactly like this, and it will reach him the same time 2t to reach the top, but we're not interested in this. We just have this body falling down, and it falls here, and the only way to do it, if this is the half of the total time, so this is 1/2 t. Okay, and then we have this body falling from the top. It covers, because this is a parabola, 1/2 time, double time. So if this is 1/2 time and this is a full time, the full distance is 4 times versus this. So we can say that this is full distance is this, and this distance is 1/4. So this is 1/4, this is 3/4, and so the distance is 3 to 1. This distance where they meet, it is 3 to 1. The ratio would be 3 to 1 because it is 3/4 over 1/4, and it would be 3 to 1. And this is such an interesting math, but it's very simple, and all you have to remember is draw a picture, remember the main formulas, remember the main results, and then try to write that coordinates are the same. Coordinates are the same. That means left side equal to right side. You put equation against t meeting time, and that's it. I hope that was useful. I hope you liked it. If so, subscribe, bell, like, write your question, write your comment, give me your problem, I will solve it for you gladly. Thank you.